Okay, greetings one and all, and welcome to this math lesson. In this math video, we'll be considering Paper 2, Bgcse Math 2022, Pass Examination. Let's begin. Okay, here we have the front page of the Mathematics Paper 2, Bgcse Examination. This is not the entire thing, this is just part of it. And so let's begin. The first question says the distance around an Olympic track is approximately 1,312 feet. Correct to the nearest foot. Write down A, the lower bound of the actual distance around the track, and B, the upper bound of the actual distance around the track. So here for this question, they want us to find the lower bound and the upper bound. But how do we find the lower bound and the upper bound in general? Well, in order to find the lower bound and the upper bound, we have to do 3 steps. The first thing we have to do is we have to halve the degree of accuracy specified. So whatever degree of accuracy that they give us, we have to divide that by 2. Then if we want to find the upper bound, we have to add to get the upper bound. And if we want to find the lower bound, we have to subtract to get the lower bound. And so let's do that. Notice that here they say that we have to write it. Notice that here they say that correct to the nearest foot. And so we have to halve that degree of accuracy. So the nearest foot means 1 foot. And so we got to do 1 foot divided by 2. So we got to halve that degree of accuracy. So since they say the nearest foot, they mean 1 foot, which we have to divide by 2, which is going to give us 0.5. Now we have to take this 0.5, and since we're trying to find the lower bound, we have to subtract to get the lower bound. So we're going to take 1,312 feet and then subtract it to get the lower bound. So we subtract 1,312 and 0.5, and we get 1,311.5. That is the lower bound. Now, in order to get the upper bound, so that's the lower bound, 1,311.5 feet. Now, in order to get the upper bound, we have to, again, half the degree of accuracy specified. They say to the nearest foot, which means 1 foot. And so we have to take 1 foot and divide it by 2. And that's going to give us 0.5 feet. Now, in order to find the upper bound, we have to add to get the upper bound. So we take 0.5 feet and we add it to 1,312 feet and we get 1,312.5. So that means that the upper bound is 1,312.5 feet. Let's move on to the next question. Here it says solve the inequality 7 minus 5x is less than or equal to 17. The first thing that we're going to do is we're going to send the 7 over, and it is a positive 7. So when we send it over, it's going to be a negative 7. So here we have negative 5x is less than or equal to 17 minus 7. Now we're going to subtract 17 minus 7 is definitely 10. And so we have negative 5x is less than or equal to 10. Here we're going to divide both sides by negative 5. And if we divide both sides by negative 5, we can cancel that with this, that negative 5 on the bottom and the negative 5 on top, leaving us with just x. And here we have x is greater than or equal to 10 divided by a negative 5. Notice that because we divided by a negative, we're going to change the inequality sign. We're going to change the direction of the inequality. So every time you're dividing by a negative when you're doing inequalities, you have to change the direction of the sign. So here it is x is greater than or equal to 10 divided by negative 5, and 10 divided by negative 5 is definitely negative 2. So here we have x is greater than or equal to negative 2. Part B says represent the solution set from part A on a number line. And so we have to write our number line. We have to find negative 2 on the number line. There is negative 2, and we're going to shade this circle. The reason why we shade this circle is because there's a line underneath this sign. If there wasn't no line, we're just going to have, if there wasn't a line, we just was going to leave this circle unshaded, just going to put a circle on the top of negative 2. But since there is a line underneath, that means that we have to shade negative 2. So that means we include negative 2 as a part of our solution. So x is greater than or equal to negative 2. We already shaded in, indicating that we include negative 2 as part of our solution. But now we have to do all of the numbers that are greater than negative 2. So the numbers that are greater than negative 2 would be negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all in this direction. So our arrow would be going in this direction to the right. Let's move on to question number 3. We have x divided by 5 plus 7x divided by 3. The first thing that we need to find is the LCM of 5 and 3. So we list the multiples of 3, 3, 6, 9, 12, 15, 18. And we list the multiples of 5, 5, 10, 15, 20, 25, and so on. Now, the LCM of these two numbers is definitely 15. And so we're going to multiply 5 to get 15 and multiply 3 to get 15. Well, 5 multiplied by 3 is 15. Whatever we do to the bottom, we must do to the top. So x times 3. And then 3 times 5 gives us 15. Whatever we do to the bottom, we must do to the top. So we multiply 7x by 5. X times 3x is definitely, sorry, x times 3 is 3x. And 5 times 3 is 15. So we get 3x over 15. 7x times 5 is 35x, and 3 times 5 is definitely 15. And so now we have these two fractions that have the same denominators. Now we can add the numerators. So we have 3x plus 35x, and 3x plus 35x is going to be 38x over 15. And that's how we get our answer, 38x divided by 15. Okay, let's move on to the next question. Here we have 45g divided by 8. Sorry, yeah, 45g divided by 8. And this whole fraction divided by 15g squared divided by 24. In order to do this, the first thing we're going to do is we're going to change this division sign into a multiplication sign, and then we're going to flip. So basically, the rule is you keep, switch, flip. So you keep 45g over 8, you switch the division sign to a multiplication sign, and you flip. What do I mean by flip? Well, what we mean is, that means that, let me use a different highlighter. When we flip, we mean we take the 15g squared, put it at the bottom, and we take the 24, we put it at the top. So KSF, keep, switch, flip. So every time you're dividing two fractions, use that rule, KSF, keep, switch, flip. We keep this first fraction, we switch this division sign to a multiplication sign, and we flip this particular fraction. Okay, so we put the 24 on top and the 15g squared at the bottom. Now we just have to multiply these two fractions. Now, in order to multiply these two fractions, what are we going to do? Well, we have to multiply 45g times 24, and 45g times 24 is 1080g. And then 8 times 15g squared is going to be 120g squared. And now we still have to simplify, right? So we have g squared, which can be written as g times g. We can cancel out this g with that g. And so we are just left with, and we also could, so we cancel this g with this g. And then in order to deal with the numbers, we can divide both top and bottom by 120. So divide the top by 120, divide the bottom by 120. And so we get 9 divided by 1, because 120 divided by 120 is 1. And 1080 divided by 120 is 9. And so we have 9 divided by 1 times g. There's only one g left, right? This g is already canceled out. This g is already canceled out. And so we have 9 divided by 1 times g, which is going to be 9 divided by g. And that's our answer, 9 over g. Okay, let's move on to the next question. It says a rectangle is shown below. And so we have a rectangle. The length of the rectangle is x plus 9 centimeters. That's the length. And the width is x minus 1. That's the width. They say form an expression for the perimeter of the rectangle. Now, when we talk about perimeter, perimeter is the distance around the shape. So for the perimeter, we have to include this side. But this side is the same thing as this side. They're the same length, they're equal in length. So if this is x plus 9, this side must also be x plus 9 as well. All right, so both of them is going to be x plus 9. And the same thing for the width, right? If this is x minus, if this side is x minus 1, right? Then this side must also be x minus 1, all right? Because for a rectangle, opposite sides are equal. So this is x minus 1. Okay, so both sides are x minus 1, both sides are x plus 9. So if we're trying to find the perimeter, we have to add up all of the sides, all right? To add up all of the sides. And so let's do that. So we have x plus 9, because x plus 9 from this one, x plus 9 from that one. And then we have x minus 1, because x minus 1 from this side, and x minus 1 from that side. Now we just have to combine all of the like terms. So all of the x's we're going to bring together, this x plus this x plus this x plus this x. We bring all of the x's together. So we have 1, 2, 3, 4, 4 x's. And all of the numbers we bring together. So this 9, this -1, this -1. So 9 plus 9 minus 1 minus 1. Now, here we have 4 x's. So we have 1, 2, 3, 4. So x plus x plus x plus x is definitely 4x. And 9 plus 9 is going to be 18. And 18 minus 2, minus 1, and minus 1 again is definitely going to be 16. And so here we have 4x plus 16. We deal with all of the x's, we add them up. And we deal with all of the numbers and we add them up. And so we get 4x plus 16. We cannot simplify this further because these two are like terms. These two are unlike terms, rather. 4x is not a like term with 16 because this one have an x attached to it and this doesn't. So we leave it just like that. That's our expression. Okay, the next question says, given that the perimeter is 64, form an equation and find the value of x. Well, we know the perimeter, an expression for the perimeter is 4x plus 16. That's what we just calculated. But they tell us explicitly that the perimeter is 64 centimeters. That means that if we add up all of the sides, we should get 64. So we set our expression that we got from part A equal to 64. Now, what are we going to do? Well, we're going to solve this linear equation. We're going to send 16 over the equal sign. And so it was a positive 16. When we send it over, it becomes a negative 16. And so we have 4x equals to 64 minus 16, which is going to be 48. We divide both sides by 4. And so we cancel this 4 with that 4. So we get that x is equal to 48 divided by 4. And so that means that x is equal to 12. So we found the value of x. Now let's move on to the next question. It says, state the width of the rectangle. Well, we know that x is equal to 12, and we know that the width of the rectangle is x minus 1. And so that means that the width, seeing that we know that x is 12, the width is going to be 12 minus 1 because we replace x with 12 because we know that x equals to 12. So 12 minus 1 is definitely 11. So that means that the width is 11 centimeters. I'm supposed to put 11 centimeters here. So centimeters, 11 centimeters. Okay, so centimeters. That is the width. All right, let's move on to the next question. Question number 5. It says, Mr. Ferguson earns $12.50 per hour for a 40-hour week as a construction worker. He is paid double time for any hours worked in excess of 40 hours. Calculate his wage for a normal working week. So we know that he works 40 hours for a normal working week. And for each hour, he's paid $12.50. So to calculate his wage for a normal week, we're going to multiply $12.50 by 40. And if we do that, $12.50 multiplied by 40, we get 500. Now let's move on to part B. It says we want to figure out his hourly overtime rate of pay. Notice that he's paid double time for any hours worked in excess of 40 hours. So double time for any hour that he worked overtime. So double time just basically means that we have to multiply his hourly rate by 2 because it's double time. Double means 2. So we're going to say 2 multiplied by his hourly rate, which is 2 times $12.50, which is going to be $25. So that means that for overtime, every hour of overtime that he worked, he's paid $25 for that. Let's move on to part C. Here, we want to calculate his wage for a week in which he works 48 hours. Well, 48 hours, we have to figure out how many hours he work normal week. And then we have to figure out how many hours he work for overtime. So how many hours of overtime did he work? So hours of overtime work is going to be 48 hours minus 40 because he normally works 40 hours. And so that means that 48 hours minus 40 is going to be what? 8 hours. And what that 8 hours mean is that 8 hours represents the amount of overtime hours that he worked. Okay. So we know how many overtime hours he worked. He worked 8 hours overtime, and for his normal regular work week, he worked 40 hours. So 40 hours normally, normal week hours, and then 8 hours overtime. So let's figure out his overtime pay for the 8 hours work. But we know for every hour overtime, he's paid $25. That's what we just calculated. So if he work 8 hours overtime, he's going to get paid 8 times 25, which is going to be $200. So for his overtime, he get paid $200. So in total, how much would he get paid? Well, he got to get paid for his normal regular working week, plus we got to add his overtime pay. And so it's going to be normal wage, which we calculated earlier, which is 500 plus 200, which means that for this week, he's going to get $700. Let's move on to part C. It says calculate the number of overtime hours for a week in which he earned $800. So if he earned $800, how many hours of overtime did he work? Well, let's take away all of his normal working wage money, right? Let's take away his weekly pay, his normal weekly pay. Let's take away that, right? So we're gonna say 800 minus the normal wage, or his weekly pay, his regular weekly pay. And we know his normal wage is going to be 500. And so that means that 800 minus 500 is 300, which means that he got $300 in overtime, right? $300 in overtime. So how many hours did he have to work in order for him to get $300 overtime? Well, we just have to divide 300 by 25 because he gets $25 for each hour of overtime that he works. So we have 300 divided by 25, which is going to be 12 hours. So the overtime hours, or the amount of overtime, or the amount of hours that he worked overtime is going to be 12 hours. Okay, let's move on to the next question. It says, while visiting Canada on a conference, Laura converted $825 BSD to Canadian dollars at the rate below. One Bahamian dollar is equal to 1.31 Canadian dollars. So calculate the amount of Canadian dollars that she received. So she has 825 Bahamian dollars. She converted to Canadian dollars. And we know that the rate is one Bahamian dollar equals to 1.3 Canadian dollars. So all we need to do in order to figure out the amount of Canadian dollars that she received is multiply 825 by 1.31. And we get that the Canadian dollars that she received, the amount of Canadian dollars received was 1,080.75. Okay, so let's move on to the next question. It says her expenses for her stay were $150 Canadian for 2 nights, right? Sorry, 150 Canadian dollars per night for 2 nights, 45 Canadian dollars, 45 Canadian dollars. Her food was 135 Canadian dollars, and miscellaneous items is going to be $110.75. So we want to calculate her total expenses in Canadian dollars. So we know, based on the question, they gave us her expenses. For a hotel, she spent 2 nights for $150. For transportation, it was 45 Canadian dollars. For food, it was 135 Canadian dollars. And for miscellaneous items, she spent $110.75. So how much was her total expenses in Canadian dollars? Notice that it says total. So total here is very important. Total, when we say total, total means that we're going to add. So it says total. So total means we have to find the sum of all of our expenses. All right. So we have to add these. So let's go total expenses. It's going to be $150 plus $150. Why $150 twice? Well, she had 2 nights at the hotel. So 150 plus 150 plus 45 for transportation plus $135 for the food plus $110.75 for miscellaneous items or for miscellaneous expenses. And so when we add all of them, we get $590.75. And so that's what we get for our total expenses. Now, the next question says, after paying these expenses, Laura converts the remaining balance back to Bahamian dollars. Calculate the amount of Bahamian dollars she received to the nearest cent. So let's figure out the subtraction. So we have to find the difference first. So let's take away her expenses from the amount of money she had. So it's $1,080.75 minus her expenses, which was $590.75. And so this is going to be equal to $490. So her expenses, so the amount of money that she had left, right, after her expenses is $490. And so what we're going to do is, in order to figure out the amount of Bahamian dollars she received, we're going to take this 490 and convert it back into Bahamian dollars. In order to do that, we're going to say $490 divided by $1.31. So $490 divided by 1.31, and we get $374.045815. But they say to the nearest cent. And so that means that we have to look at 4, right? And we have to look at the number behind 4. The number behind 4 is 5, so that means we're going to round up. So it's going to be 374.05 because 4 plus 1 is definitely 5. So this is the amount of Bahamian dollars that she received to the nearest cent. Okay, let's move on to the next question. It says a group of 252 students were asked to pick their favorite pizza topping. The same number of students picked bacon and chicken. The results are shown below. So bacon and chicken are both X because the same number of students that pick bacon pick chicken. So it's the same amount. So they want us to figure out what is angle X. In order to figure out angle X, what we have to remember is that the sum of the angles in the triangle, if we add up all of these, the sum of all of the angles, not in a triangle, but the sum of all of the angles in a circle, right, adds up to 360 degrees. So angles around a point add up to 360 degrees. What does that mean? That means that 70 plus 100 plus 30 plus x, all of them should add up to 360 degrees. So let's write that equation. And so now what we're going to do is we're just going to solve this equation for x. So x plus x is definitely 2x. We just write these other numbers down. Now we're going to add these numbers. 30 plus 70. 70 plus 30 is 100. Plus 100 again is going to be 200. And so we have 200 plus 2x equals to 360. Send that 200 over. We're going to have 2x equals to 360 minus 200. And 360 minus 200 is definitely 160. We say 2x equals to 160. And so we divide 2x by 2. And then we cancel the 2 with this 2. And so we get that x is equal to 160 divided by 2. And 160 divided by 2 is definitely 80. So that means that x is equal to 80. That means that we have 80 students who picked bacon as their favorite topping, pizza, and 80 students who picked chicken as their favorite pizza topping. All right, let's move on to the next question. It says, how many more students like pepperoni than mushrooms? So we have to first figure out how many students like pepperoni and how many students like mushrooms. And so let's do that. Number of students that like pepperoni, we're going to say it was 100 degrees. We're going to put 100 degrees over 360 because 360 is the total. So we have 100 divided by 360. That's the fraction. And that's going to be the fraction of the number of students that are there, which is 252. So we have the fraction, right? 100 over 360, which represents the fraction of pepperoni. And we're going to take that fraction and multiply it by the amount of students that were asked in the survey. So we have 100 times 252, which is going to be 25,200 divided by 360. And then we'd say 25,200 divided by 360 is definitely 70. So 70 students like pepperoni. How many students like mushroom? Well, the number of students that like mushroom, we're going to say 30 divided by 360 because that's the fraction of students that like mushroom. And we're going to multiply that by the total amount of students that are there. 30 times 252 is going to be 7,560. And 360 times 1 is going to be 360. We divide these two numbers and we get 21. So that means that 70 students like pepperoni, but 21 students like mushroom. And so to find how many more students like pepperoni than mushrooms, we're going to subtract. And so we get 70 minus 21, which is going to be 49. And so our answer is 49. So 49 students like pepperoni than mushrooms. Okay, let's move on to the next question. It says, write in lowest terms the fraction of students who like sausage. All right, so if we were to write the fraction of students who like sausage, it's going to be 70 degrees, right? 70 degrees divided by 360. So 70 divided by 360. Now, what we need to do is simplify this fraction. We can move out the zeros by dividing both top and bottom by 10. So 70 divided by 10 is 7. And 360 divided by 10 is going to be 36. And so since 7 is a prime number, we can't find any number which can divide into both of these evenly. And so it's just 7 over 36. So let's move on to the next question. It says, solve the following pair of simultaneous equations. And so we have this simultaneous equation. We have 3x plus 5y equals to 44.5. And we have y is equal to 2x plus 5. So we have two equations that we have to solve. All right, so let's move on. So the first thing that we have to do is label our equations. We're going to call this one equation 1. We're going to call this one equation 2. And the first step is to substitute equation 2, this equation, into equation 1. And then we're going to solve for x. So let's do that. We're going to take equation 2 and put it inside equation 1. So what is equation 2? What is equation 1? Equation 1 is 3x plus 5y equals to 44.5. And then we're going to take equation 2. We're going to take equation 2, right? Take equation 2, this equation right there. Take equation 2 and put it inside of equation 1, right? So wherever we see y, we're going to put 2x plus 5, right? Because equation 2 says y is equal to 2x plus 5. So we're just going to put 2x plus 5 inside of equation 1. All right, if we do that, what do we have? Well, we have 3x plus 5, open bracket, 2x plus 5. Sorry, we have 3x plus 5, open bracket, 2x plus 5, close bracket, equals to 44.5. Now what we're going to do? Well, we're going to distribute. Definitely we're going to distribute. So we're going to take, we're going to say, okay, 5 times 2. Did I have it? Okay, let me actually show it to you all now. Let me show you the distribution. Let me erase our link so we can actually see it. So we have 5 times 2x, right? That's going to give us 10x. And then we have 5 times 5. That's going to give us 25. And that's what we have here. 5 times 2x is going to give us 10x. And then 5 times 5 is going to give us 25. All right, and that's how we're going to do it. Okay, next we have 3x plus 10x. And 3x plus 10x is definitely going to be 13x plus 25 is equal to 44.5. Now we're going to send the 25 over the equal sign. So when we're going to take the 25, right? Take the 25 and send it over the equal sign. All right. And it was a positive 25. Now, when we send it over the equal sign, it becomes a negative 25. And so we have 3x equals to 44.5 minus 25. We perform the subtraction. 44.5 minus 25 is going to be 19.5. And we divide both sides by 13. And so we get that x is equal to 1.5, because when we cancel this 13 with that 13, we get x. And when we do 19.5 divided by 13, we get 1.5. So x is equal to 1.5. That's our first variable that we solve. Now we're going to use that variable and solve for y. So step 2 is take x equals to 1.5 and substitute it into equation 2 to solve for y. What is equation 2? Well, equation 2 is y is equal to 2x plus 5. That's what we have right there. This is equation 2. And we're going to take x, which is equal to 1.5, and put it into equation 2 right there. So we have 2 times 1.5 plus 5. And 2 times 1.5 is definitely 3. And so we have 3 plus 5, which is definitely 8. And so that means that our answer is x is equal to 1.5 and y is equal to 8. That's our answer to the simultaneous equation. Okay, let's move on to the next question. Here we have this one. It says d is equal to v plus ut all over 2 is a particularly useful. Sorry, the formula d is equal to v plus u all times by t divided by 2 is particularly useful in the study of physics. Transpose the formula to make v the subject of the equation. And so we have to make v the subject currently. D is the subject of this equation, but we have to make v the subject of this equation. So the first thing that we're going to do is we're going to distribute this t. So we're going to say t multiplied by v, and we're going to say t multiplied by u. And so what we have? We have t multiplied by v, which is vt, and t multiplied by u, which is ut, all over 2. So we have d1 is equal to vt plus ut all over 2. Now we're going to cross multiply. So we have 1 times vt plus ut, and we have 2 times d. What is 2 times d? 2 times d is 2d, and 1 times vt plus ut is vt plus ut, all right? And so now, since we have VT plus UT, this is very important. What we're going to do is we have 2D is equal to VT plus UT. Remember our goal, we need to solve for V. So we don't need this UT right here. We want only V on this side, all right? So we're going to send the UT over because we just want VT on this side, right? And eventually we're going to get rid of the T, but the first step before getting rid of the T, let's just get rid of this one first, all right? So we're going to send this UT over because we just want this term by itself because it has the V and we want V to be by itself, all right? So we send the UT over and so we have 2D minus UT, which is going to be equal to VT. And so we still want V to be by itself. We still want to isolate V. So we're going to divide both sides by T because we're going to get rid of that T. We cancel this with that. So we left with V is equal to 2D minus UT all over T. And so we just switch it and write it a different way, which is going to be equal to V is equal to 2D minus UT all over T. And that's how we find the value of V. Or rather, that's how we make a V, the subject of this equation. Let's move on to the next question. It says the polygon is a regular polygon. It's a regular decagon. So that means it has 10 sides. Calculate the size of the angles. The first angle we have is X, and X is an interior angle. So this is an interior angle. That's what X is. And they want us to figure out the size of angle X. We know that this thing has 10 sides. And so in order for us to find out the interior angle for this decagon, we're going to use this formula. The formula says if we want to find out the interior angle of a regular polygon, we just need to multiply 180 by n minus 2 all over n, where n is the number of sides. And in this case, n is 10 because this thing has 10 sides. It's a decagon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 sides. And so we have that n is equal to 10. So let's put n is equal to 10. So we put 10 in this case and 10 at the bottom. And so we have that 180, open bracket, 10 minus 2, close bracket, all over 10. So we have that the interior angle is going to be equal to 180 multiplied by 10 minus 2, all over 10. What is 10 minus 2? 10 minus 2 is 8. So we have that 180 multiplied by 8. And what is 180 multiplied by 8? That's going to be 1,440 all over 10. So 1,440 divided by 10. And when we divide that, we get 144. So that means that the interior angle of this decagon is going to be equal to 144. The next question says that calculate the value or calculate the size of angle Y. Now, we know that every one of these, let me see, do I have it? Okay, yeah. Every one of these, let's make this clear here. So what I'm trying to say is that if we look carefully, right, every one of these in here is 144. So this is 144. All of the interior angles are 144. All of these is 144. All right. We just calculate that. That's 144. This is 144. Okay. All right. This is 144. All right. This is 144. All of the interior angles are 144. This is 144. This is 144. Right. And this whole thing right here, which C is a part of, is 144. All right. Now, these are what we call the interior angles, right, of this polygon. Now, if we want to consider the exterior angles are going to be the ones on the outside, which I have out here, right? These are the exterior angles right there. These are the exterior angles, one on the outside, right? All of these. Y is an exterior angle. This one is an exterior angle. This one right here, if we were to draw it out as well, is going to be an exterior angle as well. And if we were to draw this one as well, this one is going to be an exterior angle, all right? And this is the exterior angle as well. So the ones that are on the outside there are what we call the exterior angles, right? So, okay, so if we look carefully, they asked us to find out the value of Y. Well, we already know that this one right here is 144. And if you look carefully, these angles are on a straight line. So Y and 144 is on a straight line. What do we know about angles on a straight line? Well, angles on a straight line at a common point add up to 180 degrees. And so that means that 144 plus y is going to be equal to 180 degrees. So in order to figure out the value of y, we're just going to subtract 180 and 144 to get 36. And so 36 is the exterior angle. So the exterior angle is 36, the interior angle is 144 for this decagon. Okay, let's move on to the next question. This one is interesting. We have here, it says that we want to calculate the size of z. Okay, so in order for us to figure out the size of z, we need to notice this formula. The rule says that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3. So if we have a regular polygon, like we have, this is a decagon, and we're trying to figure out how many diagonals will come from one vertex, then it will be, in order for us to figure it out, it's gonna be n minus 3, where n is the number of sides. And so each vertex of this decagon has 10 minus 3 diagonals, which is going to be 10 minus 3, which means it's going to have 7 diagonals. What does that mean? That means that if we come to this particular vertex, we should be able to draw 7 diagonals from this particular vertex right here. So how many diagonals can we draw? This one. That's one diagonal. This is 2 diagonals. This is 3 diagonals. This is 4 diagonals. This is 5 diagonals. This is 6 diagonals, and this is 7. So it is true. If we come to this particular vertex, we're able to draw 7 diagonals from this particular vertex. And it's the same thing for each vertex here, right? Every vertex that we have for this decagon, we are able to draw 7 diagonals. Now, why is that important? Well, it's important in us finding what z is, right? So if we know that each of these diagonals, if we know that we could draw 7 diagonals, right? What we need to figure out is what is the amount of degrees that is in between these diagonals, right? Now I have here 18, but how did I get 18? Well, I got 18 because remember that if we remember the total, let me highlight this over there. If we remember the total, right? The total size of our interior angle was 144. That was the total. So the total size of our interior angle is 144. But how many spaces do we have? Well, we have 1 space, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, right? And we have 8. So we have 8 8 spaces, right? And so that means that we have to take 144, which is the interior angle, and we have to divide it by 8 to figure out how many, what is the size of these little spaces here. And when we do that, we get 18. And so that's why we have for each one of these, it's 18. So that means for each one of these little spaces, it measures 18 degrees. Now let's look at z. Well, z only accounts for what? 2 of these spaces, right? That's what z is. Z only accounts for 2 of these spaces. That's what z is, right? Z only accounts for 2 of these spaces. And so what does that mean? That means if we're trying to find z, right? Remember, z is this angle right there. Z only accounts for 2 of these spaces. So that means if we're trying to find z, we just need to multiply 2 times 18 because it only accounts for 2 spaces. And each one of those spaces is 18. So 2 multiplied by 18 is going to be 36. So that means that z equals to 36 degrees. Okay, let's move on to the next question. For number 11, they want us to factorize. So we have 63m to the third power, 63m to the third power n plus 28m n squared minus 7mn. And so in order for us to factorize this particular expression, we have to figure out what is the highest common factor. Like what could we find in each one of these, right? So what is common in each one of these terms, right? Well, we know that 7 is common because we could use 7 to divide. I mean, because 7 could go into 63 and 7 could also go into 28 and 7 could go in itself. So we know 7 is common in all of them. That's the first thing. And we also know that m is common. Isn't m common in all? So m is common. M is here, right? M is here, and m is also here, right? So m is common. So 7 is common. M is common. What else is common? Well, n is common. N is here, n is here, and n is here. So the common factor, that is a common factor for each one of these terms in this expression, is 7mn. And so we're going to use 7mn as the one that's going to be out front, all right? Now, we're going to take 7mn and basically try to figure out how we can get these numbers back up, this expression back to the top. What do I mean by that? Well, we say, okay, 7 multiplied by 9. What is 7 multiplied by 9? That's going to give us 63. And m multiplied by m squared is going to give us m to the third power. And we just attach the n right there. Now let's go on to the next term. So we have 7, right? 7 multiplied by 4, that's going to give us 28. We put m there because m is right here. And this is n squared. So we have to put n here because n times n is going to be n squared, all right? And then all we need to do for the last one is we need to multiply 7mn times 1 to get 7mn. And so this is how we factorize this particular expression. Okay, let's move on to the next one. Here we have to simplify this particular expression. We have 3 open bracket 2x minus 3 minus 4 open bracket x plus 7. Here we're going to distribute. We're going to say 3 times 2x, and we're going to say 3 times 3. And then we're going to say negative 4 times x, and we're going to say negative 4 times 7. Now, what is 3 times 2x? Well, 3 times 2x is 6x. What is 3 times 3? Well, 3 times 3 is 9. And we put the negative sign. What is negative 4 times x? Well, negative 4 times x is going to be negative 4x. And what is negative 4 times 7? Well, negative 4 times 7 is going to be 28. Now we have to combine the like terms. So 6x and negative 4x. So we have 6x and negative 4x. We combine them, put them together. And then we have negative 9 and negative 28. We combine them together because they are numbers. So we have the ones that, the expressions or the terms that have x in them, we put them together. And the expressions that are just numbers, we put them together. So 6x minus 4x is going to be 2x, right? So 6x minus 4x is 2x. And then negative 9 minus 28, well, negative 9 minus 28 is definitely going to be negative 37. And so the answer for our, so the answer to this expression that they want us to simplify is 2x minus 37. Let's move on to this next question. Here we have to simplify this expression as well. We have 2p to the third power divided by q, all raised to the third power. So we're going to take this 3, right? And we're going to use it to deal with the numerator. We're going to use it also to put at the denominator. So we're going to put it for the numerator and the denominator. And so let's do that. So let's erase our link. And so we have 2p to the third power raised to the third power. So we applied it to the number at the top, the term at the top. And we have q to the third power. So we applied that to the bottom as well. Now we're going to apply it to every term inside of this bracket. So we're going to apply it to the 2, and we're going to apply it to the p to the third power. And so now we have 2 to the third power, and we also have p to the third power raised to the third power as well. Now q to the third power is just q to the third power. That doesn't change. What is 2 to the third power though? That's 2 times 2 times 2, which is going to be 8, right? And then when we have p to the third power, all raised to another power out front, we can multiply these two numbers. That's what the formula says. If we have a term raised to a power and raised to a power again on the outside, we have to multiply these two powers. And so we have 8p all raised to the power of 3 times 3. And 3 times 3 is definitely 9. So we have 8p to the power of 9 divided by q to the third power. And so our answer is 8p to the power of 9 divided by q to the third power. Let's move on to this next question. Here we have a bearings question. It says that the scale drawing below shows the relative distances and directions of Bird Key, Nassau, and Spanish Wells to each other. So we have Bird Key right here. We have our north here. We have Spanish Wells. We have another north, and we have Nassau. And it says that given a scale of 1 centimeter equals to 6 kilometers, measure and state the distance in kilometers between Bird Key and Nassau. So you have to find the distance between Bird Key and Nassau. All right, so let's actually get a ruler and measure it out. So if we actually measure it out using a ruler, we have Bgcse and we have Nassau. All right, and so let's figure out the distance from this, right? Let's figure out the actual measurement. Now we have the zoom in. Let me zoom in. And so this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. And this is 6.1, 6.2, 6.3, 6.4. So that means that our measurement is going to be 6.4 centimeters. Again, notice this is 6, 6.2, 6.3, 6 point, sorry, this is 6, 6.1, 6.2, 6.3, and 6.4. All right. And so that means that our measurement is actually 6.4 centimeters. So the distance is going to be 6.4 centimeters, but they want it in kilometers. We already know that 1 centimeter is going to be 6 kilometers. So we're going to take our 6.4 and multiply it by 6. Why? Because 1 centimeter equals to 6 kilometers. So if we have 6.4 centimeters, we multiply it by 6 to figure out how many kilometers we have. That's going to be 38.4 kilometers. That's the distance between Bgcse and Nassau. Let's move on to the next question. Here we have, they want us to determine the bearing of a Nassau from Bgcse. So we have to go to Bgcse. You have to go to Bgcse. Every time you're trying to do bearing, you have to start at the particular location that they said from. So it says from Bgcse. So that's where we got to start, right? From Bgcse. We got to go from Bgcse to Nassau. So it's going to be Bgcse. We're going to start at our north. They already established our north for us, so that's good. And we're going to move in this direction. You always go clockwise. So you start at your north and then go clockwise until you reach the line for Nassau. All right. So this is the angle that we're trying to find. This angle right here. This is the angle that we're trying to find. And so let's use our protractor to figure out the angle for this. So this is Bgcse, right? This is Bgcse, and this is Nassau. Remember, we're trying to find this particular angle right here. And if we're trying to find this particular angle, we're going to use the numbers on the top, the numbers at the top. So we start at 0, this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, right? And if we zoom in, did I zoom in? Yes, let's zoom in. If we zoom in, this is 120, okay? This is 120, this is 125 right here. 125, 126, 127, 128. Okay, so this is 128. Let's do it again. This right here, this line, this is 125, because this is 120. This one right there is 125. This right there is 125. This is 126. This is 127. And this right here is 128. And so our measurement, our bearing is going to be 128 degrees. So the bearing of Nassau from Bgcse is 128 degrees. Let's move on to the next question. Here they want us to determine the bearing of Bgcse from Spanish Wells. So from Spanish Wells, which means that we have to start at Spanish Wells, construct our north. Good thing our north is constructed. We got to go clockwise from this north all the way to Bgcse, the line for Bgcse. This is the angle that we're trying to figure out. We're trying to figure out what is the measurement of this particular angle. Like how much, what is the size of this angle? All right. So in order for us to figure out the size of this angle, what we're gonna do actually is we're going to figure out what is the size of this angle, right? And if we can figure what is the size of this angle, all we need to do is subtract this angle from 360 to get the one in red. So you're going to figure out what is this angle, this one in blue. So this from here to here, we're going to figure out that measurement. And once we get this measurement, we're going to subtract it from 360 to get the one in red. Because angles around a point or angles in a circle measures 360 degrees. So one revolution is 360 degrees. And so what we're going to do, we're going to figure out the distance from here to here. So if we do this like this, and here to here, so this is Spanish Wells. And if we look carefully, this is going to be what? We start at 0, and this is going to be what? We use the ones on the outside, so it's going to be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay, so it's on 110. Okay, so that means that this right here is 110 degrees. Right, this is 110. But like we said here, we have to subtract it. We have to subtract it from, we have to subtract it from 180. Let me erase all link. So this right here is 110. So we're going to subtract it from 180. So we know that this right here, we just calculate that. This right here is 110 degrees. Okay, 110 degrees. And so what we're going to do is we're going to take 360 and subtract it from 110 to give us 250 degrees. And so that means that the bearing from Bgcse and the bearing of Bgcse from Spanish Wells is actually going to be 250 degrees. All right, that's our bearing. Okay, let's move on to the next question. It says Andros is 45 kilometers from Nassau. If this information were included in the above diagram, calculate the distance on the drawing in centimeters. So here's the thing. They gave us kilometers and they want us to convert it to centimeters. What do we know? Well, we know that 1 centimeter is actually equal to 6 kilometers. So if we get 45 kilometers, how many centimeters would that be? Well, we just have to divide. So we have to divide 45 by 6, and that gives us 7.5 centimeters. And so our answer for this one is 7.5 centimeters. Let's move on to the next question. Here we have a trigonometry question. It says find the length AB. So where's the length AB? Well, the length AB is going to be this particular length. That's the length AB, right? And if we look at this, this is actually a right angled triangle, all right? And if we look carefully, right, this side is 8 centimeters and this side is 24 centimeters. We just have to figure out what is this side, right? What is this side? And we call this side the hypotenuse, right? What is the length of the hypotenuse? We are given 2 sides. We just got to find one side, and it's a right angle triangle. So we definitely going to use Pythagoras theorem. And so let's go ahead and do that. So we have Pythagoras theorem, which says c squared equals to a squared plus b squared. We're gonna call this side, we're gonna call this one A, right? We call this side, we're gonna call it B, right? And we're trying to find C, the missing one, AB. So C is our hypotenuse. Okay, so A is 18 centimeters, which we just denoted here. B is 24 centimeters, which we have here. So we have 18 squared and 24 squared. What is 18 squared? Well, 18 squared is going to be 324. What is 24 squared? Well, 24 squared is going to be 576. And we're going to add them together. So we get 900. Now we're going to, we have to figure out like what is c squared. So we're going to take the square root of both sides to get rid of this square. So the square root and the square cancel each other. So we left with c is equal to the square root of 900. What is the square root of 900? That's definitely 30. So c is going to be equal to 30, which means that AB equals to 30 centimeters. Okay, let's move on to the next question. It says, find BAD correct to the nearest whole number, BAD. Now this is an angle that we need to find, and they tell us BAD, so let's look at that. BAD. So this is the particular triangle that we're looking at, this one right there. And they want us to find out this angle, this angle, because they say BAD. So they're actually referring to the one in the middle, this one. So we need to figure out what is BAD, all right? BAD. So what do we have? What do we know that we have, right? Well, we know, right? We already know that we have, let me use red. We already know that we have this side, we have 24. We have 18 centimeters, and we have 30 centimeters, right? Now, this is the angle that we're trying to find. If we go across, right, this will be what we call our opposite. So the side that is opposite the given angle is the opposite side. So this will be called the opposite, right? So it's going to be the opposite, right? And then this is our right angle triangle. And the side that is opposite the right This is our right angle, and the side that's opposite the right angle is definitely the hypotenuse. Call this the hypotenuse, right? And so we have the hypotenuse and we have the opposite. And so the one that's left out is the adjacent. So the third one is the adjacent. So this one right here is the opposite. This one right here is the hypotenuse. And this one right here is the adjacent. And so, let me see, erase all these things. So we could use SOHCAHTOA. Like I said, that this right here is the opposite. This is the hypotenuse, and this is adjacent. So we have all three sides. So we could use any of the three trig ratios. So sine says you can, in order to figure out sine, you need the opposite and the hypotenuse. In order to figure out cosine, you need the adjacent and the hypotenuse. In order to figure out tangent, you need the opposite and the adjacent. So we can use any one of these three because we have the opposite and we have the hypotenuse. We have the adjacent and we have the hypotenuse. We have the opposite and we have the adjacent. So we can use any one of these trig ratios. I am going to use tangent. So tangent of theta is going to be equal to opposite over adjacent. The reason why I chose tangent, like I said, because you could use any one, but I chose tangent because I didn't want to use 30. 30 was the one that we solved, and I typically don't like to use the one that we solved for, because what if you're wrong? What if we miscalculated? What if our Pythagoras theorem was off? So you typically want to use the sides that they give you, if you can help it, right? Sometimes you can't help it, but if you can help it, use the size that they give you. And if we're using the size that they gave us, which is 18 centimeters and 24 centimeters, 18 and 24, well, that's the opposite and that's the adjacent. So that's tangent. So tangent is going to be opposite over adjacent. The opposite is 18 centimeters. The adjacent is 24 centimeters. We want to figure out what is theta. So we got to take tan inverse of both sides. And if we take tan inverse of both sides, this cancels out with that. What did we just do? Well, we're trying to figure out what is theta. And tan is in our way. Tan is the problem. We need to get rid of tan. So in order to get rid of tan, we have to do the opposite of tan, which is do the tan inverse of tan. And tan inverse with tan cancels out. But we can't just do tan inverse on one side. Whatever we do to one side, we have to do the other. It's an equation. So we are left with theta is equal to tan inverse of 18 over 24. So because we took tan inverse on this side, the tan inverse and the tan cancels out, leaving us with theta. And when we took tan inverse of this side, we put tan inverse of our fraction that we have here. And so we have tan inverse of 18 divided by 24. You can put this inside of your calculator. So tan inverse of 18 divided by 24 is going to be 36.86989765. But they want it to the nearest whole number. So we have to look at this number, which is 8. It's greater than 5. So we're going to add 1 to 6. So we're going to be, theta is going to be equal to 37 degrees. So BAD, angle BAD, this angle right there, right, is going to be equal to 37 degrees to the nearest whole number. Let's move on to the next question. Here we have angle. Here we have defined BCD. What is BCD? Okay, so B is here, C is here, and D is here. So we're looking at actually this triangle. So BCD. It is again a right triangle, so that's good. That means that this side right there is the opposite. No, this right here is a right triangle. So this right here, this side is the hypotenuse. So the side that is opposite the right angle is the hypotenuse. What angle are we trying to find? BCD. So we're trying to find what is C. So this is the given angle right there. We need to figure out what is this angle right there. So the angle, the side that is opposite the angle is going to be the opposite side. So this is going to be the opposite. All right. So, and what else? And the one that's left is the adjacent. Okay. So what are we trying to find? We're trying to find angle BCD. So we're trying to figure out what is this angle right there, this missing angle. What do we know? Well, we know what is the opposite. Do we know the adjacent? No, we don't know the adjacent. Do we know the hypotenuse? We don't know the hypotenuse. BCD. BCD. So how are we gonna figure this out? What did I use? Oh, this one is easy. I was doing all sorts of things. No, we don't need to go through all that. What we need to do is, this is funny. This is good. So here's the thing. So if you look carefully, this is a bigger triangle here, right? That's a bigger triangle. And if you look carefully, this right here is 90 degrees. So that's 90 degrees for the triangle. We already know, we just figured out that this is 37 degrees. If you're trying to figure out what is this angle, it's angles in a triangle. So if this is 90 degrees and this is 37 degrees, we just need to add them together and then subtract it from 180, and then we're going to get our answer. So 90 plus 37 is 127, and 180 minus 127 is definitely going to be 53. So this angle right here is actually 53. Okay, so this is 53. How do we figure that out? Well, we know that the sum of the angles in a triangle is 180 degrees. Okay, so it's 53 degrees. Okay, let's move on to the next question. It says, all right, find the length BC correct to 3 significant figures. Now we got to go to this particular triangle right there, the smaller one. This one right here, B. We need to find the length of BC. So we're looking at this triangle because this is the length BC, that is the hypotenuse. So again, the angle that is opposite the right angle is the hypotenuse. This is the hypotenuse. The angle that is opposite the given angle is the opposite. So this right here is the opposite side. The opposite side. And the one that's the left over is the adjacent. Okay. So we're trying to find the hypotenuse. Let's look at SOHCAHTOA. We're trying to find the hypotenuse. Let's not forget that BC. So since we're trying to find the hypotenuse, we cannot use TOA. Why? Because TOA, the only thing you could find with tan is the opposite or the adjacent. We're not looking for the opposite or adjacent. We're looking for the hypotenuse. So we either could use sine or we could use cosine. Why? Because cosine, you could find the opposite. Here, for cosine, you could find the hypotenuse. Sorry, for sine, you can find the hypotenuse. And for cosine, you can find the hypotenuse because both of them have h. So we could either use sine or cosine, but we cannot use tangent. Why? Because tangent, you only could find the opposite or the adjacent with tangent. You cannot find the hypotenuse. And so we move the tan, move that away. We can't use that. So it's either sine or cosine. Which one we gonna choose? Well, do we know the adjacent side? No, we don't know the adjacent side. So yeah, we can't use cosine either because we don't know the adjacent side. So can't use that either. So the only thing we could use is sine because we know the opposite. The opposite is 18 centimeters, and we trying to find the hypotenuse. So we could use sine. Why are we using sine again? Because we have the opposite, which is 18 centimeters, and we are trying to find the hypotenuse, which is unknown, but we can find it because we could use the sine formula, which has h in it, right? Which has the hypotenuse accounted for. So that's how you think through choosing which trig ratio to use. We can't use tan because it doesn't have the opposite or the adjacent. We could have used cosine, but the only problem is we don't have the adjacent side, so we can't use cosine. The cosine would have been good because we're trying to find the hypotenuse. But if we had the adjacent, then we could have used cosine, but we don't have the adjacent. We can't use cosine. For sine, we have the opposite, which is 18 centimeters, and we're looking for the hypotenuse. So the hypotenuse is accounted for, so we could use sine. So sine is the trig ratio that we're going to use for this particular one. Let me raise our link. So again, the opposite is 18. The hypotenuse is what we're looking for, and we have 53 degrees as our angle. So the formula says sine theta is going to be equal to opposite over hypotenuse. The opposite is 18 centimeters, the hypotenuse. We don't know. The theta is the given angle, which is 53. So theta is 53, the opposite is 18. Hypotenuse, we don't know, so we call it x. Now we're going to cross multiply. So we're going to put sine 53 all over 1 equals to 18 over x. We cross multiply. So x times sine 53 is going to be x sine 53. And 1 times 18, well, that's just 18. Now we're going to divide both sides by sine 53. Divide both sides by sine 53. This cancels and this cancels. We are left with x is going to be equal to sine 53. And what is x divided by sine 53? I'm sorry, what is 18 divided by sine 53? Well, that's going to be equal to 22.53844.185. I said that wrong. 22.53844.185. Let's walk through what we did again. We multiplied, well, the first thing we do was we substitute. So we took theta, we put it as 53. We took the opposite, we put it as 18. The hypotenuse, we don't know what that is, so we put x. We cross multiply, x times 50 sine 53 is sine 53. So we have x sine 53. And we have 1 times 18, which is just 18. Here, our goal is to isolate x. So we're going to divide both sides by sine 53 to get rid of the sine 53. So we just could be left with x. So we put sine 53 at the bottom, sine 53 at the bottom. We cancel the sine 53 with this sine 53. And so we get that x is equal to 18 divided by sine 53. And so x is going to be equal to 22.5384185. We wanted to correct the 3 significant figures. Well, this is a significant figure, 2. This is a significant figure, 2. And this is a significant figure, 5. Let's look at to the right of 5. That's a number lower than 5. And so we're just going to keep it the same. So it's going to be 22.5. So BC, correct to 3 significant figures, is going to be 22.5. Okay, let's move on to this next question. It says, in the above diagram, object A is transformed to produce image B. Fully describe this transformation. Okay, so let's look carefully. The answer that I have here is that this is going to be a rotation of 90 degrees counterclockwise about the origin. Now, why would I say that? Why do I think it's a rotation? Well, it can be a reflection. Just looking at it doesn't look like a reflection. Like if it was a reflection, it would have been a mirror image, and that doesn't work. But why do I say it's a rotation of 90 degrees counterclockwise about the origin? Well, we just have to look at the points, analyze the points, and see how they match with one another, and then you can understand why I chose that. So let's look at the first point. The first point on this image right here is 2, 2, right? And if we rotate that point, we get negative 2, 2. Look carefully. Here we have the point right there. This is negative 2 and 2. So this point was rotated here to get negative 2, 2. Okay, let's look at the next point. We have 1, 3, the point 1, 3. So this is the point 1, 3 right here. And notice carefully that we rotated that point 1, 3 to get the point 3, negative 3, 1. And so this is the point negative 3, 1. So this point 1, 3 was rotated such that we get the new point negative 3, 1. Now let's move on to the next point. We have 2, 5. 2, 5, 2, 5, 2, 5. 2, 5 is here. This is the point 2, 5. Now, that's the point 2, 5. Now let's rotate this point. If we rotate this point, we get negative 5, negative 2. Let's look at it. Negative 5, sorry, we have negative 5, positive 2. So negative 5, positive 2 is going to be right here. And let's take another point, 4, 3. And if we rotate it again, we get negative 3, 4. And negative 3, 4 is right here. Okay. So if we look at it, so we have this point, negative, positive 3, sorry, positive 4, 3. And when we rotate it, we get negative 3, 4. So if we look carefully, we see a rotation going on, right? We see that each one of these points corresponds to another point, which is the point on B, in a systematic way. Now, what is the pattern? Notice, all of these are negatives, right? All of these are negatives, right? And notice the pattern. All of these, look at it carefully, it's kind of weird, but all of these, right? All of these y values, well, they became our x values. Look, 2, 2, 3, 3, 5, 5, and 3, 3. So all of our y values became our x values. Only thing is we negated it. So again, what was the trick? All of our x values from our original thing, which is 2, 3, 5, 3, all of those x values became our y values. 2, 3, 5, 3. Okay. The only thing is that we negated it, right? So basically all we did was we switched, and guess what? All of our x values, guess what? They became our y values. Look, 2, 2, 1, 1, 2, 2, 4, 3. So all of our y values became our x values, only thing we negated them. And then all of our x values became our y values. And so what is that? How do we interpret that? Well, if you know the formula for rotation, well, there's it right there. This is the formula for rotation, a 90-degree rotation counterclockwise. That's it right there. It says if we are performing a 90-degree rotation, if we have our pre-image, the point of our pre-image, which is regular XY, what we're going to do in order to figure out the point after rotation, what we're going to do is we're going to take our Y value and make it our X value. So that's why we have a negative. Sorry, we're going to take our Y value and put it in the X value slot. So we have X and Y. So we're going to switch them. So we have Y and X. So X and Y, and then we switch them, and then we negate the Y value. Right? And that's exactly what we did. We took our XY, we switch them, then we just negate the Y value. All right, so again, we took our X and Y, we switch them, right? And we negate the Y. And that's exactly what we did. And so if that's what we did, if that's what we're seeing, then it's definitely rotation counterclockwise of 90 degrees. All right, so it's a 90-degree rotation counterclockwise. And so that's how we can verify that this is definitely a rotation of 90 degrees counterclockwise about the origin. Okay, let's move on to the next question. Here we have question B. It says on the graph paper, using a scale of 1 centimeter to 1 unit for each axis for -6, is that not equal to x? Is that not equal to 6? Sorry, is that not equal to 9? And 5, -5, is that not equal to y? Is that not equal to 11? Draw and label a copy of object A. Okay, so what they're basically saying is that for our x values, we only can go from -6 to 9. And for our y values, we only can go from -5 to 11. And so let's actually draw this. So again, for our x values, we only can go from -6 to -9. And notice carefully, we only went from -6 to +9. Okay, so we only go from -6 to +9. And so we went from -6 to +9 on the x-axis. For the y-axis, we only can go from -5 to +11. So we went from -5 to what? +11. All right, the +11. And so we did it right. And so what else do they want us to do? They want us to draw and label a copy of object A. Well, object A, the coordinates are 2, 2, 1, 3, 2, 5, and 4, 3. And so if we look at our image that we have, it's 1, 3, right? 2, 2, 2, 5, and then 4, 3. So this is exactly our object A that we have here. We draw it and we label it. Okay, so that's that. Now, what else do they want us to do? They say draw the label image of A after reflection across the line y is equal to 1. Label this image C. So they want us to perform a reflection, and they want us to perform a reflection across the line y is equal to 1. If we do a reflection across the line y is equal to 1, y is equal to 1 is going to be this line. It's going to be a horizontal line passing through y. Sorry, passing through 1. So this is the line y is equal to 1. It's going to be a horizontal line passing through 1 on the y-axis. All right. And so then we have to reflect our image A in the line y is equal to 1. Okay, so this is the line y is equal to 1. It's going to be a horizontal line passing through 1 on the y-axis. And so if we notice, we're just going to reflect it. So this is what? 1 space. This is going to be 1 space. So that's where this point is. This is what? 1, 2 space. So this is going to be what? 1, 2 spaces. This is going to be what? 1, 2 spaces. So it's going to be what? 1, 2 spaces. And for the next one, let me erase this. So they have to be equal distances apart, right? That's what the reflection does. And so again, this is going to be 1, 2, 3, 4 spaces away from the line of reflection. So this point is going to be 1, 2, 3, 4 spaces away from the line of reflection. And so that's how we do it. We have to make sure that they are equal distances apart. And so that's how we find each one of these points. And as you can see, and we have to label it, right? So image A and image C are reflections of each other, right? You can see that because they're equal distances apart and one is a mirror image of the other, okay? Okay, let's move on to the next question. They say translate A by the vector -5, -6, label this image D. Okay, so you have to take each point on this particular image A, and apply the vector -5 and -6 onto it. So the first point that we're going to use is 0.22, and we're going to add -5, -6 to it. We know that 2 plus -5 is going to be -3, and then 2 plus -6 is going to be -4. So our point on our translated image is going to be -4, sorry, -3, -4. Then we're going to take the point 1, 3, which is right here. We're going to add -5 and -6 to it. So we have 1 plus -5, which is going to be -4, and 3 plus -6 is going to be -3. And so we have the point -4 and -3. Now we have 2, 5, so 2, 5 right here. 2, 5, we're going to apply the vector -6, sorry, -5, -6 to it. 5 plus -5, sorry, 2 plus -5 is going to be -3, and 5 plus -6 is going to be -1. And then we're going to apply the last point, so 4 and 3. So we have 4 plus -5 is going to be -1, and 3 plus -6 is going to be -3. So these are going to be our points for our new image. Our image labeled that we're going to label D, right? So these are going to be our points. And so let's apply it. -3, -4. So -3, you have -3, -4. So that's that point right there. -3, -4. And then we have the point -4, -3. So -4, -3. And we have the point -3, -1. So we have -3 and -1 right now, right? And then we have -1, -3. So we have -1, -3. And this is our new image. We just connect the dots and then we label it D. There's another way we could do it. Remember they said that the vector is -5, right? -6, which basically means that we're going to go to the left 5 times. We're going to go down 6 times. And so let's do that. So let's use this point. So we're going to go to the left 5 times and down 6 times. It's going to be 1, 2, 3, 4, 5, and then down 6 times. So it's going to be 1, 2, 3, 4, 5, and 6. And so we get to this point. And you could do it for each one of these points. So you can say 1, 2, 3, 4, 5, down 6, 1, 2, 3, 4, 5, and 6. And you could do it for each one of these points to get the point as well. All right, let's move on to the next question. Okay, what's the next question? Oh, okay, the next question. Did I even put the question there? I don't think I even put the question there. But the next question, let me see if I put it before I even show it. Did I put that question there? Okay. So let me insert the question into this because they want us to enlarge it. So I didn't put the question there. So let me put the question in there, and so you can actually see the question, and then I'll resume the recording. Okay, for this question, this is question 4. They say an enlargement of scale factor 2 from the origin maps A onto E. Draw and label the image of this transformation. So they want us to take this particular image and enlarge it, right? Using a scale factor of 2, all right? And so let's do it. Let's go ahead and do that. So if we have to take each point and basically multiply each of those points by 2, remember the scale factor is 2. Our first point is 1, 3. If we multiply that by 2, we have 1 times 2 is 2, and then 3 times 2 is 6. So this is going to be our new point. Then we have 2, 2. That's another point on our graph. And 2 times 2 is going to be 4, and then 2 times 2 is going to be 4 as well. Then we have the 0.25. We're going to multiply it by 2 as well. 2 times 2 is going to be 4, and then 5 times 2 is going to be 10. And then for 3, we have 4 times 2 is going to be 8, and 3 times 2 is going to be 6. And so our new points, right, for the points for our enlargement is going to be 2, 6, 4, 4, 4, 10, and 8, 6. And so let's go ahead and actually plot this. So 2, 6, 2 here, 6 is here, that's 2, 6, 4, 4, we have 4, and then 4, and then 4, 10, we have 4, and then 10, okay? And then 8, 6, 8, 6, we have 8, and then we have 6, 8, 6. And so this is going to be our enlarged image, which we call E, all right? All right, that brings us to the end of that particular question. Here we have, this is a graphing question. They said that answer this entire question on the graph paper provided. Using a scale of 1 centimeter to 1 unit, that means we're counting in ones, draw and label the X and Y axis for -2. So they want us to go from -2 to 6 on the X axis. And on the Y axis, they want us to go from -8 to 6. They say draw the straight line joining the points 0, 4, and 3, and -5. This is nice because all we need to do is plot the points 0 and 4, and 3 and -5, and then join them. So let's go to our graph. Remember, -2 to 6 on the x-axis. Remember, that's what they told us. -2 to 6. And then -8 to 6. Remember, that's what they told us. We have to go from -8 to 6 on the y-axis. So -8 to 6 on the y-axis. Now, what points do we have to plot? We have to plot the points 0, 4, right? 0, 4, which means 0, 4. So we go up on the y-axis. This is the point 0, 4 right there. And then the next point is 3, -5. So we have 3 and -5. That's the point right there. So now we just got to join those points together and get our straight line. There we go. So 0, 4, and then 3 and -5. Let's move on to the next question. It says, find the gradient of the line from part B. Okay, the gradient. So the gradient is the slope, all right? So the slope is going to be equal to, notice that we have 0, 4, and 3 and -5. That's the points on the graph. So in order for us to, find the slope or the gradient, we have to use these 2 points. What are the points? The points is 0, 4, and 3 and -5. What does that mean? That means that this 0 right there is x1. This 4 right there is y1. This 3 is x2, and this 5 is y2. And so we have x1 is 0, y1 is 4, x2 is 3, and y2 is -5. And we're going to plug that into our equation. Remember, notice that the equation for the slope is given by, or gradient, is y2 minus y1 all over x2 minus x1. And so y2 is -5, y1 is 4. We subtracting them. X2 is 3 and x1 is 0. We're going to subtract them as well. So -5 and -4 is -9. And then 3 and -0, 3 minus 0 is 3. And so we do 9 divided by 3, -9 divided by 3. And this is very interesting how I wrote it, because notice carefully, right? Let me do it for you. So we have m, right, which is the slope, is equal to -9, right? -9 divided by 3, okay? -9 divided by 3. What is -9 divided by 3? Well, -9 divided by 3 is definitely negative 3, okay? Negative 3. So the slope is actually negative 3, okay? I put negative 3 over 1, right? Because if you notice that when we are looking at like how to actually, draw a line, and the slope helps us to draw the line. So the negative 3 can tell us, how we're moving on the y-axis, and, so we have rise over run. But you don't have to have negative 3 over 1 and just leave it like that. We can continue this and finish it off. So we don't have to have it like that. So the slope is going to be equal to negative 3 all over negative 3 divided by 1, which is going to be equal to negative 3. Okay? So you don't have to leave it as negative 3 over 1. I would suggest that you simplify it. And I should have simplified on this particular screen. So m, which is the slope of the gradient, is going to be equal to negative 3. So let's write that down. The gradient of the line is going to be equal to just negative 3. Okay? Negative 3 is the gradient. We don't have to keep it in fraction form. All right, let's move on to the next question. It says, copy and complete the table of values for the line y is equal to 2x minus 6. Okay, so we have to figure out, if we look carefully, right? Let's go back. These two slots were missing. And so that's what we have to figure out. Like, what are the values of this slot and this slot? Okay, and that's what we have to figure out. Okay, so let's go back. So we have here x is equal to negative 1. So you have to use this equation to find it out, right? I already have it. I already have the answers in. But let's imagine that we don't have the answers. We're trying to figure out the value of the missing value here and the missing value here, right? Because they were not given. So what we do have is that x is equal to negative 1. That's this part right there. So x is equal to negative 1. What we're going to do is we're going to take that negative 1 and we're going to substitute it into our equation. So wherever we see x, we're going to put negative 1. So we have 2x minus 6. Instead of putting x, we're going to put negative 1. So 2 times negative 1 minus 6. So we have 2 times negative 1, which is negative 2 minus 6. And negative 2 minus 6 is going to be negative 8. So y is equal to minus 8. Next, we have x is equal to 5. Now, why do we have x is equal to 5? Because if you notice here, we have 5 right there. So the x value is 5. And so we're going to take 5 and substitute that into our equation. So we have y is equal to 2 times 5, because x is 5, minus 6. 2 times 5 is 10, and 10 minus 6 is 4. So y is equal to 4. So that means that when the x value is negative 1, the y value is negative 8. And when the x value is 5, sorry, what does that mean? That means that when the x value is negative 1, the y value is negative 8. And when the x value is 5, the y value is 4. Okay, so when the x value is negative 1, the y value is negative 8. When the x value is 5, the y value is 4. Let's move on to the next question. It says, state the coordinates of the y-intercept of the line. Oh no, before we even get to F. E says, draw and label the graph y is equal to 2x minus 6. So we just figured out the coordinates of these, right? We literally just figured out the completed table. And so we're gonna take each point on this table and we're gonna literally graph it out. Okay. Remember that this is a negative 8 and this is positive 4. So our first point that we're gonna graph is a negative 1, negative 8. So let's do that. So negative 1, negative 8, that's our first point. The next point is positive 1, negative 4. So we're gonna have a positive 1, negative 4, that's where this point is. The next point is 3, 0. So it's gonna be 3, 0, that's gonna be this point right here. The next point is 4 and 2. So 4 and 2. So 4 on the x-axis, 2 on the y-axis. The next point is 5 and 4. That's gonna be 5 and 4, okay? And so let's draw on that line. Remember, we already had the first line drawn. we're going to draw on the second line. All right. And so that's what we have. So this line that we just drawn, the purple line, that is the line y is equal to 2x minus 6. Okay. And this is the previous line that we already had. Okay, let's move on to the next question. They asked us, what did they say? They said, state the coordinates of the y-intercept of the line y is equal to 2x minus 6. Now the y-intercept, or the y-intercept is going to be the point where this graph crosses the y-axis. So this, at this point right there, this is where, the same point, this is where the graph crosses the y-axis, and that's the point 0, -6. This particular point right there. So the answer for this one is going to be, let's go back. The answer for this one is going to be 0, 0, comma, -6. That's going to be the answer for this one, 0, comma, -6. And then for G, they want to write down the coordinates where the two lines intersect. So where does the two lines intersect? Let's go back here. The two lines intersect at the point 2, -2. That's the point of intersection, 2, -2. And so we're going to put that right there. The point of intersection is going to be 2, comma, -2. That's the point of intersection, 2, comma, -2. All right, and that brings us to the end of this video. Thank you for watching, and I'll see you in the next video.